Hello all, welcome back to CyberCreed. Today in this video we going to be discussing about the Gemini 1.5 Pro which the Google have recently launched, which is now available for the people with the API key that have the public access. So we are going to see how we can leverage its 1.5 million context length window, and we will be seeing all of its use case because now it's a multi-modular, which means we can ask by passing the image, we can pass it just by passing the text. So we are going to be looking at all of these things: how we can pass the simple text and get the output, how we can pass the text as well as the image and get the output, how we can just simply pass the image and get the output, as well as how we can pass 1 million context length text and how much time that it actually takes to give the result back. So that all we will be discussing today. But before I move forward, I would like to show you this Gemini 1.5 video or the blog that they have published. And here, let's try to see this quick video tutorial that will give you more in-depth knowledge what the Google have launched. And this is coming straight from the Google. So let's see.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 402-page PDF of the Apollo 11 transcript, which comes out to almost 330,000 tokens. We started by uploading the Apollo PDF into Google AI Studio and asked, find 3 comedic moments, list quotes from this transcript, and emoji. This screen capture is sped up. This timer shows exactly how long it took to process each prompt, and keep in mind that processing times will vary. The model responded with 3 quotes, like this one from...
So like this, we can basically pass a long text content and it is able to respond towards that. And now let's move on to the next feature, that is the passing the image, and let's see how it is planned.
If we go back to the transcript, we can see the model found this exact quote
they are verifying it.
comedic moment accurately. Then we tested a multimodal prompt. We gave it this drawing of a scene we were thinking of and asked, what moment is this? The model correctly identified it as Neil's first steps on the moon. Notice how we didn't explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details. And for the last prompt, we asked the model to cite the timecode of this moment in the transcript. Like all generative models, responses like this won't always be perfect. They can sometimes be a digit or 2 off. But let's look at the model's response here. When we find this moment in the transcript, we can see that this...
So these are the things that I just wanted to show, and if you have already gone through it, you already know, like we can pass the image, we can ask the answers in the very large context and how useful it is going to be. So without wasting any further time, we can just jump onto the code and see how we can simply use it. So before moving ahead, please make sure that you have created a virtual environment, first requirement, and second, we will be using some of the requirements. Let me just open up my terminal. So the first thing that you have to make sure is that you have the API key of the Google Gemini. You can simply go to the Google Studio and get the API key, and make sure that you created a .env file, put your Google API key there, and then we can start working with that. So the first thing that I would like to show you is that we will be using LangChain because this is used everywhere you might be using currently in your project. So it becomes very easy to integrate Google Gemini. So we don't need to use the Google native. If you want to use it, you can simply go to the Google documentation and use it. But here we will be focusing on the Google LangChain. And because we can simply use it, plug it with any model out there because it's already open source and it supports all the different type of models. So for that, let's search LangChain Gemini. So here is the chat, here is the Google AI chatbot models. So here are the things that you have to install. You can just simply copy it, LangChain, Google, Genie, and Pillow. So you can just copy it and install it. But I already have created a virtual environment and installed it, so I am not going to do it here. So now let's start by importing some of the libraries and see how we can firstly make some simple input-output call like we do with any other models. So first important thing is that here, just ignore this. This is to ignore the warnings that might come because the LangChain is moving so fast that every update is providing some context. So it's always good idea to create a virtual environment and save those requirements into your requirement.txt file. So here I am importing this particular library, which is Chat Google Generative AI, which is used for chatting with the Google. And here is the human message and the system message that we will be looking in some time. And again, here we are saying python.env load env. This is to load the environment variables from our .env file. And we are importing OS because that is what we are going to use to get that environment variable into our file. So now let's move forward. And here, this is the name of the latest model. The model name is Google Gemini 1.5 Pro latest, which is the current name. It might change in future, but it is latest. So it's the name is also latest for now. I hope they don't change, so it will not contain the conflict. But anyway, so the name is Gemini 1.5 Pro latest. So previously here on the LangChain documentation, if you see, it was Gemini Pro for the text-based communication and Gemini Pro Vision for image-related chat. But now they have created the multimodal, which means this Gemini 1.5 Pro latest have the capability to answer both in text as well as in your images. So that is one of the very good things that they did. And here, if you come to this website, you can save your .env like a Google API key with this name, Google API key, and then paste your API key in your .env file. So let me open up the. So here in the .env, you have to just do that. Make sure that you have the .env file with those credentials. I will not be sharing mine. So once this are set, now let's move forward and try to see how we can make the simple call. So here what I did is basically like any other model, llm.invoke. So here we have basically defined our model, chat agility by passing the model name. And then we are just invoking it, calling write a blad about the LangChain. And here we are trying to print the context. So now let's try to run it inside our terminal and see what it is going to give. So I will not be using this terminal so that we have the plenty of space to see. I will be using my other terminal and I will be running it. I am inside the same code, Gemini. So once I run the code, let's see how much time it is going to take. So what we are doing, we are trying to ask it to write just some basic things. So this is the simplest approach that you can ask any LLM out there. So let's see how much time it is going to take. So yes, it have done and it took around 14 milliseconds. So it have written something about our LangChain and things like that. This was the most simple use case. But now let's move forward and see how we can simply try to use it with multimodal functionality. Let me comment this out and let's move on to this. So here, if you remember, we have imported this human message and system message. And why we are taking this? So if we move to this, and here you can see that Gemini does not support system message yet. But in the current version, which I am particularly using, it's already updated, and the Gemini document and this LangChain documentation is yet not updated. That's why I say the document, even this framework gets updated faster than its own documentation. So here we have to basically define the model, and then we can pass the system message in this format and the human message in this format where we need this. So here I have created this particular function, and the use of this function is that if we are simply going to pass just the text, not the image, that is just going to return us the response like it was doing here. But if we are passing the text as well as the image, it is going to be using this context of the text as well as the image. So you can pass the image, and let's suppose you pasted a screenshot of the problem on the lead code, and you also want to paste the text that please write the solution of it in big of n time using Python or C++. So you want to provide a particular programming language information alongside that particular image. So in that case, it will be useful. Or if you just pasted some image, and if there is just the image URL and the text does not exist, so this will be called, where you have to just the image URL and you don't care about the text. So here what we are doing, so message is equal to human message, and the context we are passing as the text, whatever the text the user have given. And here elif image URL, which means any one of these will only run, not all of them. So if there is image URL, we are setting the human message, and here the human message is the content, and here is the type, which is the image URL, and then we are simply passing it. So once it's set, whatever, let's suppose I pass any text, so it is going to be fitted inside the model, and once this is done, this message pass is done, this result will come, and we will invoke again with the particular message. Either it's having the image URL or it does not have that. We are going to invoke them, and then we are simply going to return whatever the content of it is. So now let's try to run this with this particular image URL first, because we have already seen about the text. And let me show you the image first. So this is the image where one people is riding the bike and other peoples are doing the bull race. And let's see what our model tries to predict. We are just simply passing the image URL, nothing else. So let me run the code. And again, here we are passing the image URL, which means you can either pass the image that is inside your local documentation, or you can also provide the image URL that is over the internet. So it does not care that you have to download and parse things like that. You can just pass the image URL from anywhere in this galaxy. Okay, so it took 9 seconds. So here it says the image portray a block cart race taking place, or the payload likely a ruler setting bull cart race, and the photographer capture the excitement. Yes, it is able to detect that. Here on the image, if you see, this camera is in the size of this particular camera is very small, but it was able to figure out that he is trying to film something using his camera, so which is very good thing. So here we have just tested it out with the particular image, and now let's move forward. And now let's try. So here you can basically use it with just passing the image as well as the text and multiple of things, and you can test it out. I will be providing this code in the video description so you can check it out. And yes, if you are enjoying till now, please make sure to like this video, and I will make the latest and the latest video related to AI, Python, or any cybersecurity things. So yes, with that said, here I am trying to create my agents. So what are agents? So agents are, so in agents you basically set something at first, like, hey, you are a news summarizer, you are a JSON parser, you are a comedian who tells joke, and then we ask, now tell the joke about this. So that is what we are trying to do here. So here we have set the model as Chat Google Generative AI, which is similar to the above where we have set this. So we might not need this, but here again, here's the important thing. Here we have to say model, and then here we are basically passing the system context, and then we are invoking it. So now let's test it out. So here see very carefully. I have basically taken this particular example from this only, but I have just added a twist. So instead of just yes or no, which might be possible that the system can easily get without using its additional brain. So sometimes it may get yes, but here what I said, answer only in 0 or 1. 0 means no, 1 means yes, which is the binary in computer science. And then we are going to ask, is this fruit? Is apple a fruit? And here we are passing the text. So text is this, and here answer only in 0 or no, which means yes or no. So so it is just going to return the output in 0 and 1. So here you can see how we can basically make use of it inside our web application. So a user can ask questions, and we are going to get the response in 0 and 1, and we can compare it. So system, whatever question you are going to ask, like is Modi the president of India, it is going to return 1 because he is. So things like that will just provide that particular answer. So this is what the system prompt is set to. And now let's try to run it up. Let's clear the screen, run this code, and yes, the deprecation warning is coming. And yes, here you see the response is 1, which means yes, apple is fruit. So now let's move forward and try to see what most of you might be interested in. So let me just comment this first. Now here we are going to see what the 1 million context length comes in handy. Here I have this Sherlock Holmes.txt, which have multiple chapters of Sherlock Holmes. So now let's try to calculate the tokens that are basically present. So we can say token counts, things like that. And okay, here is the website that we can paste the token. And so here I pasted, you see it's more than 31,689, which means this text is very large, and most of the models are not going to work with it. So here what we are going to do, here we are opening our Sherlock Holmes the txt file, which is here. Here we are reading the story and stripping the additional unnecessary spaces, because I see there are multiple unnecessary steps, unnecessary space and line breaks that are there, which are already going to be useless for our model. So I have just stripped it to remove all those extra spacing out there. And here I have, let me show you. Here I have provided a system prompt. You are the story summarizer who can summarize the story, blah blah blah, answer only the summary in 200 words. So I have suggested it to summarize this entire long concept in just 200 words. And yes, as this is much more bigger, it's going to take much more time. So let's also try to time this up. And also let me just ignore the warnings. Okay. So it is not working in that way. So let me just try to paste it here and let's run the code so it don't give the deprecation warning. And I'm going to time it. Python time main.py. So here now it is going to take entire documentation, and previously we would have to use our vector databases, but the Gemini, as it can take very large context window length, it is going to consume all of this information, and then we can continue asking the questions ahead. As you have seen on the website documentation, that was a simple UI presentation, but here we are coders, we are here to create, not to consume most of the time. But that is what we are trying to create, as shown in the video where the women have basically uploaded a PDF file and tried to ask some questions. And yes, I can't trust on the timing. It is saying 0.48 seconds, really. So here it is basically able to summarize this entire bit documentation. So like this, you can basically make use of it. And if you simply want, so here is for agents, where you want to basically use agent. This is that function that I have basically written. And this is the multimodal chat, where we can simply pass the image, and also with the image, we can pass the text. So let's see how we can basically use that. So multimodal chat, and here also we can say text is equal to, based on this image, write a story about it in 500 words. Okay, so I have the spelling checker because I usually make lots of spelling mistakes, which is not good at practice at all. So let's try to test it. We are passing the image, and as well as we are passing the text. Based on this image, write the story. Let's see if it is going to work. Python main.py. So with that particular image, it will see what is inside that image, and with that information, it is simply going to create a story. So you can just imagine the use case that you can basically use it for. So here you see, this is the story. The dust rose in the plums behind the hurtling bull cart, swinging, dancing in the golden afternoon light, praise the pieces of the wood frame, made to grip, blah 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 blah. And this sounds like a story that is basically written by an AI. But anyway, this was all the information that is available till yet, and these are all the different features that you can use. And now this is the toolkit that I have provided, and with this tools and this information, you can create your own different functionality available. You can simply use these functions in your own applications and try to use it in the way that you would love to use it. And if you found this video useful, I would really appreciate if you can like the video and share it with your friends who are interested in the fields of AI or working in the fields of AI. And also subscribe to this channel is must.